Hi everyone, welcome for another session of AppScan Tuesday. This is episode 28. And today we are going to talk with a good friend of mine, Kris Duer, about how he works with developers with the head of somewhere between security champion and an AppSec person, going over the results of a static analysis finding. So let's bring Kris in. Hello, Kris.
Hello. Thanks for having me on. Welcome to my back porch or front porch.
Glad to have you on. I had you and the rest of the Application Paranoia podcast on our 9th or 10th episode when we were just doing it live and a lot of technical difficulties. This one we are recording, so if anything goes wrong with my Wi-Fi or yours, we can fix it and the audience won't suffer too much. So, what's up?
Just living the dream. But I did want to kind of walk people through an assessment and really evaluating what the assessment is trying to tell us, what it's trying to show us, and some of the things that maybe it's trying to keep secret from us, so we can try to get the most value out of the process that we're worried about here, which is static analysis. To do that.
And because, wait, before you share, because as we discussed in the past, people should pass the step of just running scans. Right.
Yeah, that's usually what happens. I ran a scan, I get a green check mark. Woohoo! I'm good to go. No,
you are.
It's going to show you a bunch of stuff.
You're zero more secured when you run a scan.
Yeah, the only difference is you spent money to get 0% at this point, which is not good. That's not what you want. You want to get a better security posture. If that means one fix a year, that's at least one fix a year better than you were before. When we say fix, we're talking about defensive measures. You don't want to have that open door on the first floor with a neon sign that says, hack me here. You'd rather have it on the 400th floor with, a closed, locked window, possibly with bars on it. Who knows? That makes it that much more difficult for them to get in. So they go after the other people who have that open door that says, hack me here.
Exactly, because
that's the goal.
Yeah, because we're not necessarily trying to protect against the team of hackers that are targeting you as a company. You will need to do way more, but most companies out there are not being attacked that way. I mean,
no, you have to be important enough for them to invest resources to get whatever you're holding as information, and it has to cost less to get that information than it does for them to say get it from somewhere else. So you want to be that corporation that says, what, we're going to have that, window on the 400th floor. Good luck getting to it. You need a halo jump. If you have a halo jump, what can we do? But if you don't, well,
Yeah, and even if you are that important, you will do all this static analysis and dynamic analysis and IAST and all the measurements. But even then, you need to prioritize what you are going to handle first. Lock the door.
You can't
put bars
fix
on the second.
You can't attack everything. You can't protect against everything. And if they want what they want, they're probably going to find a way to get it one way or the other if they have enough money behind them.
Exactly.
You want to keep yourself out of the hands of the low-hanging fruit folks that are going to go out there, write an exploit for one open source package and say, hey, I've got access to hundreds of millions of websites now because reasons.
Because hacking is a business, right? They need to make a profit. So
they do. They sell the hacks, they sell the exploits, and it's big business. Things that most folks would probably be scared about. There's a retailer that had a problem with one of their point of sale systems, which shall remain nameless. They fixed it, and by fixed it, I mean they just locked up the database. The exploit still existed in their POS system, so they could still be attacked. It's like, this is not a fix. That's a pretty easy to go after thing. Credit card scammers, people have heard about those. Not good. That's physical security. That's something we don't attack with static analysis, but what we can show you is what happens in the code itself. We can open that door for you to say, if we find it in SAST, there's a high probability that somebody can find the path through your systems. And that's past the web application firewall, the perimeter defenses, the firewalls, the regular firewalls that you might have. All of that stuff is important, but it's not the whole picture. If you look at some of the spending that goes into application security, it's way down here where most of the exploits, way up here. So you've got to think beyond just a SIM or network or firewalls. You've got to look at the code that you're writing and make sure you're being responsible and a good steward of the trust that people are giving you.
Yeah, because you need to be proactive, right? SIM is, hey, I got hacked. Now I know about it. You want to prevent that hack. You want
that's
to
a little close in the barn door after the horse has gone out.
Yeah, exactly. So, and as we said at the beginning, it's not just about the scan. So static analysis will help you close all those doors and windows, but it's up to you to decide which windows to close and where to put the bars and which alarm to turn on. And this is where we have you on the show today.
Yeah.
Now,
So
wait, one more. If
we're
people
gonna
want to
hold
hear more about
excited.
Kris and all the stuff, because his excitement is easy to notice, I will include a link later below for the Application Paranoia podcast, which I think you're running also half a year. We started around the same time.
Yeah, we're on episode, I think, 16 coming out soon.
Yeah, we are doing it twice a month. I do it once a week.
month.
So I'm ahead of you in episode, but definitely with the content, we are enjoying both of them. Oh, and wait, I listened to the one that you just had, and you said, I won't tell you about the new thing that we are launching in AppScan soon, but we just launched it, so maybe you can share here first.
Yeah, share it here first. Steal the thunder from Paranoia.
Exactly.
Yeah, so program slice analysis, we're really excited about. It's the ability to take, in this case it's just Java, but ability to take each class file and analyze them in a vacuum apart from every other class file. And while that on a surface doesn't sound too interesting, what is interesting is we can now scan at light speed, whereas before we'd have to load the whole thing up in memory and analyze it together in memory. Now we can cut it up into pieces and parts. And the fun part about this is if we already have the answer, if we already have the analysis, we don't need to rerun it. We can just take the result and use it. So we can short circuit a lot of the processing we used to have to go through and just give you the answer that much faster, which, you know, time is money, speed is money. And if it's the same or similar enough answer, you save yourself time to get the answer of what you need SAST to give you, which is, I mean, that's always a good thing in my opinion.
And for those of you out there that think, oh, it's incremental, it's not just incremental. We're doing way more than just incremental. And Kris and I discussed before we had this show, hey, maybe we should show this. But then you realize, oh, you hear it on, whoop, there it is. The demo would go really...
Hold on, it's faster now. Woo! It's not as exciting to watch.
Yeah, but it is exciting to try it out. Yeah, so if you're an ASOC user and suddenly your Java scans run really, really fast, thanks to Kris. Any theme, yeah.
It's been a long time researching this process too, because static analysis is really hard to do. So yeah, it's pretty cool. It's pretty cool we're able to pull off with this sucker.
Yep. And now we wasted a lot of time. Let's jump to the demo, Kris.
Yeah. So we're gonna talk about what a specific assessment is trying to show you, and there are certain things.
Start sharing the screen because currently you only see a black screen.
Oh, I hit that.
We'll see you back. And yep, technology. I can see AppScan source now.
So we have a pretty basic assessment right here. And one of the first things I like to know is what kind of attack vector am I dealing with? Is it a web app? Is it a desktop app?
Kris, can you maximize it?
What's that?
Can you maximize it? Any chance?
Oh, I think that is maximized.
Okay.
Does that make it any better?
Much better, thanks.
Okay. So what I like to look at is to see what kind of attack surface we're dealing with, what kind of questions people might really be looking at to try to understand what this assessment is trying to tell me. And really, I can make a few assertions pretty quickly, which is I use a database. I probably have some kind of web interaction going on because why else would you have a cookie? So I've got this perfect storm of a web app that touches a database that probably, if we're having SQL injections of any kind, probably uses user-supplied data to make these database insertions or database deletes or selects, whatever you want to call it. So I've got myself an app that's probably very insecure. And this particular app we know is insecure. It was built that way. But for the moment, let's suspend our disbelief and pretend this is a production app that's out there in the really real world. And this is what we're seeing when we first run a scan. So in order to absorb 165 findings in the fastest possible way, there's a couple of things I like to do first, which is to see just how much quality my scan might have. And to be able to do that, I want to look at the sinks themselves, and I really want to look at lost sinks to see what kind of situation I'm dealing with. And the beauty of the new system that we have right now with ICA, which is, intelligent code analytics is we make markup for missing syncs or lost syncs so that we can get past that invisible wall of something we don't have security information for. And to take a little bit of a step back and go into how static analysis works is it builds this huge map in memory of how all of the interactions between the code that you write and the code that your program uses interacts with third-party stuff. So your get parameters going to SQL execute query, for example. And we do that so we don't have to analyze what get parameter is doing and what execute query is doing. We already know. We know that get parameter is getting something off of an internet HTTP request, and we know execute query is at some point in its chain behind that wall is making a write to a database. So we take those pieces of information and we call it markup, and we can sort of short circuit the analysis to make that giant map in memory only user code or only user written code, so the code that you write, to sort of limit the scope of the work we need to do. The interesting part of that approach is if you don't have security information for where the data stops, you don't know how much further behind that wall it might go. So what ICA does is it tries to fill in those gaps, those missing pieces of information so we can go even further, which means the lost syncs we get with the newer versions of AppScan Source are no longer really that wall where it used to be. I don't know what this is. I can't go any further. Now we get these weird little taint out of the top kind of findings that say this does a get parameter, returns the response, and somebody else is calling it. So this is telling me that I have possible sources that I might want to look into to really understand how my application uses this do get call. So if I really wanted to be thorough, I would add sources to all of these. I would say get bank user as a source. I would say get bank user again as a source, do get as a source. And all of these would actually show me some more additional findings. We're not going to do that now because we don't necessarily need to, but it gives me an idea of what I'm looking at in terms of coverage, the quality that I got out of my scan, and how much deeper I could possibly look. So once we've gotten that answer, we're going to go ahead and reset it. Once I've gotten that answer and I've figured out all of my scan coverage findings, I've filled in all of those blanks, I've gotten as far beyond the wall that I used to have as I can, now we're left with a more complete picture of what our code is trying to tell us. So I can take those scan coverage findings and just rule them out at this point because I really don't know with a scan coverage finding, we'll stay here, whether or not this particular finding is interesting or not interesting, because I don't have proof. The engine isn't sure. Scan coverage basically means I have part of the puzzle, I don't have the complete picture. And when you're dealing with 93 findings still, as opposed to the 160 some odd that we were dealing with before, it's a lot easier piece of the pie to consume. So you really can't go after every single nuanced part of this, because at some point you're gonna have to start fixing. You're gonna have to start actually changing your code to remove some of these attack vectors. And in order to do that, you need to figure out what you can go after first. I'm sure people have heard it all over the place where they say defense in depth, make sure you use SAST, DAST, and IAST, and there's a reason for that. SAST is really good at finding single stage attacks or things that, point A to point B attacks. So get parameter to an execute query, which you'll see some examples of, right here, for example. Get parameter going right into a SQL query, which means we're using user information supplied from a website to run an actual query. Horribly dangerous. So we have these proven attacks that's really easy for SAST to find that DAST may take perhaps a little bit longer. Maybe not. They pretty much find the same stuff in many cases. There's a Venn diagram of all the different things these guys can find. And SAST does find some things quicker than DAST. It's just how it works. The technology goes after source code. It doesn't have to run attack commands or anything like that. So the theory is you can get a lot faster feedback with SAST than you could with DAST in most cases. But really what you want to do is all of it. Every piece of testing you can do, you want to uncover as much as you can to really understand what your prioritization looks like.
And that helps you, basically what you just said, it helps me with the priority because I can't fix everything. Yes, there might be something that I'm hiding here because of the coverage, but you can't fix everything. You need to get to the point that you can start fixing. If you fixed everything, hey, you can go back always and add the coverage, but give me a call when that happens, right?
Right. You don't want to have analysis paralysis where you're just saying, oh, did I find everything? Oh, no, I need to go deeper on this assessment. Because you can go as deep as you want, but ultimately there is a point of diminished returns where if you spend another 2 hours on this, you're probably going to get 1.4 findings additional. And maybe DAST will find that finding for you anyway. And maybe IAST will find that for you anyway. Maybe your web application firewall would stop the attack from even happening anyway. So you really do have to figure out the fastest way possible to get to that list of gold before you can go on to the next step, which is prioritizing and triaging, giving it to somebody to actually fix. So then we go to the next stage. We look at our vulnerability types again, and I like to take a look at some of the things that DAST is really good at, and some of the things that DAST is not so good at. I tend to let go, or at least drop in priority faster than other things. So for example, I might see, well, this one has a good one, AppDOS. AppDOS is really hard to prove statically because you need to have sometimes a specially crafted node or a specially crafted document. And in many cases, you have alternative protections in place or mitigating factors in place, which static analysis will never know about. You know, only Bob down the hall has access to this particular system, for example, to put in one of these files that might have one of these AppDOS type read line attacks. If that's the case, you can probably drop the priority on that, assuming Bob is happy and, you know, you're doing good work with him and he's never attacked your company from insider attacks before. You're probably okay. But what you're not okay with is things that come from the web that you don't control whatsoever, that have no mitigating factors, that go right into a database. And sometimes a web application firewall can, and sometimes do, protect you against SQL injection attacks, but it's important to understand that some attacks just should not exist in your code. This, to me, SQL injection, cross-site scripting, any kind of injection really just should not exist in your code at all. It's so easy to defend against. I really don't understand when I see this in the wild, why it even still exists in the world today. I mean, it's a simple shift, and all it takes is a prepared statement versus a statement execute. It's not even hard. It almost makes the code cleaner and more defensible as opposed to, you know, this garbage gobbledygook that we see here. So with a whole bunch of string appends.
So I'm a developer. Well, used to be. I'm coming to you as the AppSec person, and I'm telling you, Kris, this tool is crap. I don't have this problem, right?
Yep.
This is probably the day-to-day job that many application security and security champions have.
This is what we deal with.
Or I don't understand what this tool is telling me. There is no chance that you can hack. What do you do in those cases? How do you persuade me?
Right. So I ask the questions. I say, where's the data coming from? In this case, it's coming from the web. And where's the data going to? And how is it getting there? Is it going through something? And this one right here has my favorite call, which some people have actually used to defend it, which is what they claim is a sanitizer, escape SQL. It's not, but we'll go into why it's not in a little bit. And they'll say, look, I have a sanitizer. I can't get anything bad through this, right? So we look at it. We look up what escape SQL does. And really, all it does is change a double quote or escape a single quote. That's it. It just escapes a single quote. It's not going to protect you. It's not going to really defend against an SQL attack. It doesn't really do what you think it's going to do. And in fact, there are many such sanitizers that exist that do portend to protect you. I think PHP has some of the best examples of the MySQL escape sequence calls out there that can still be attacked, that can still be injected, that have patterns that it can't handle. It's just, there are some things you can't defend against that are just impossible to figure out all the different nuanced variations of what an attack might look like. So they'll come to me and they'll say that, and I'll say, well, look, this is what it's doing. This is a really easy thing to defend against, and the cost of us changing the code to fix this is X versus the cost of us getting exploited is Y. Which one of those do you think is smaller? And in many cases, I imagine some companies do make choices where if I get exploited here, it's bad, but is it as bad as it could be? And database attacks are almost always as bad as you think they could be. But in other cases, like logging forge, is it as bad as it could be? Well, here you might be able to hide your tracks. You might be able to hide the fact that you attacked the system. And certainly from a forensic point of view, it's really, really not good. But at that point, you've also already done the damage. So is it as high as, say, a SQL injection or a cross-site scripting or even a command injection? I don't know. That's for the company to decide for themselves what matters the most to them. So the second phase is ultimately, in my opinion, prioritizing the vulnerability types that we're dealing with. And when I say the vulnerability types, it's not just, is this a SQL injection? Okay, fix it. It's also, where's it coming from? So we see a bunch of get parameter situations and guess HTTP session get in this particular app But I've also seen situations where SQL injection happens from a property file, and that property file is literally within the jar, and it's one of those, get me the right message for this call or whatever it is. That's not as injectable or exploitable as HTTP session get attribute or get parameter or things of that nature. So it's more than just a vulnerability type you need to consider. You do need to fill in the blanks that SAST can't do for you, the context around the finding, if you will. So yeah, some of the conversations do get interesting. And you don't necessarily need to go after the developer with, this is wrong, fix it. You do want to have the conversation, and you do want to understand that here's the risk, here's what we're going to give to a third-party auditor. Would the third-party auditor agree with our assessment that this is noise? And that's usually the barometer I use when I do reviews with folks is if a third party, or if I think a third-party auditor would agree with us, then we're probably going to be okay marking this as noise. And an example of that is, reading from a file on a desktop system and then perhaps spitting it out on command line, which is typically what desktop apps can do. Is that as dangerous or nasty as a command injection possibility from a configuration file for that same desktop app? Probably not. It's probably we want to fix the command injection first. So you do have the conversation to try to fill in that scope of what the finding is trying to tell you.
It's interesting. It's funny, but it also sad that the tool to persuade developers will often be that auditor instead of the risk that you will actually be breached. Well, you know that we are having audit in 3 months from now. Are you sure you want to be flagged there? Not instead of, well, you know that companies are being breached. Do you want that responsibility on your head?
Exactly. Yeah,
but
I use the third-party auditor as a barometer more to keep us honest with ourselves. If we're saying something can't be hacked, are we lying to ourselves? Are we really saying this can't be hacked because we're just like, I don't want to look at the finding. I don't care if it's coming from a parameter. It can't be hacked. Go away. Or are we being, a little bit bending the truth, saying, well, I just don't have the resources to fix it. I've got a push to put out there in production. Bug fixes don't sell product. They may keep your product in the market if you don't get attacked and exploited, sure. But do they sell product? I don't know. I don't know the last time I saw an operating system saying we're the most secure and then not pushing out a security update to keep it that way. I mean, most of them do push out security updates, and it's a quality of life improvement. It's not necessarily look at this new button or swizzle that we added. It's cool. Oh, look at this new user interface. It's exciting. None of that really sells. But what it does do is keep you in business so you don't lose the confidence that people have using your product. And that's a big deal. I mean, brand loss, brand recognition loss has hit many companies very, very hard. And they're struggling to get over that loss of identity or that loss of trust that they had with their consumers.
So Kris, we are, as usual, going all over the place. When someone uses AppScan Source, first of all, starting from version 10, I think IFA is in, and then the number of issues is dramatically more focused. I don't want to say decreased, because more accurate or more in your face, the items that actually can be exploited, we will report. Yes, you can see all of them, and I think that Florian showed it in one of the sessions. But the important thing is that we understand you need to fix those things, not just to run them. And we made it easy for you to focus. But even after that, as you showed, we had 100 and something, now down to 93. What is the magic number?
So there is no magic number. That's the fun part about this. You have what you have, and you need to accept the truth of what happens when you pull back the bed cover and you see all the bugs in your bed. You just need to accept the truth, because when you scan, you might get 10 findings. You might get 10,000. You could get any number between and even more. I've seen some scans well over 500,000 in size. You can imagine what it takes to triage 500,000 findings.
I cannot.
It turns out, with IFA, we dropped that list down to like 1,000 of important findings that we really needed to care about. So you can imagine a lot of that was just different nuances of the same finding that's really trying to tell you the same thing. So really, you need to have a plan of attack. You need to understand what vulnerability types matter for the application to your organization so you can start fixing them. And then which ones of those do you really need to dig deeper on and really understand what parts of the code matter the most. I mean, you might not spend as much energy on the cafeteria app as you would on a production system thing that you make money off of as a business. Of course, why would you, right? But really understand that even that cafeteria app has a pathway into your company or into your business through that avenue, even through people. when you look at it,
Yeah.
I think my favorite phrase or my favorite scene from Mr. Robot was I see 5 vulnerabilities right there, and there were the guards walking around. We
Yeah.
are the vulnerability, so we really need to consider protecting our code as best as we can.
But as we said originally, you can't fix everything. So there
You
is the
can't fix
business.
everything.
Yeah.
So
there
which
is the
ones do
business
you fix?
impact. Yeah, there is the business impact. Is this application important? Is it critical? What is behind it? That's one. But once you ran a scan, you have the issue types, the severity that we defined, and then you look at them and decide, okay, this is SQL injection. This is really, really bad, but the
Yes.
source from it, you can't get to it anyway, or the chances to get there, not great. All of these are usually the responsibility of the security champion.
Or analyst, yep. Usually a discussion between the two to arrive at that conclusion after they filled in the context questions. For a web app that's deployed, if it's a test app, probably don't really need to go after cross-site scripting in that case. If it's not a test app, you probably need to consider it a little bit more. So really, it's context. SAST is done in a vacuum. It always is. We don't know where this code is deployed, how it's used, who's going to be using it, how exploitable even get parameter is. I mean, if only 3 people can ever get to this page with login information, well, the exploit isn't as exploitable, even though it's coming from the web. If you can't get there without having proper authentication, and that's been proven out through pen testing, through DAST analysis, through IAST, et cetera, well, then maybe it doesn't stay as high as you thought it would.
And another
Maybe.
part that maybe explains why SaaS is what's the term in the vacuum. You may write a code, and someone may use this code in a certain way, and another group may use it in a different way. So when we run a static analysis on your code, when you run a static analysis on your code with AppScan Source or whatever, we don't know how that code is being used. If it's behind the firewall, how the application server is being used, this is just internal. That's why the context is so important. And no tool can give you that. You need to tell
No
the
tool can. I mean, even if we had SAST, DAST, and IAST all hooked together and living together in the same ecosystem, which we do somewhat, but we don't do correlation yet. But even if we had that, we still don't know. We still don't know if that web server is exposed to the world or not. We have no idea. We could ask those questions. We could fill in some of that context, sure. But really, this is where people using what we have with the knowledge we have of the environment that it's going to be deployed in, why we're still so very important. This is a tool. This is a hammer. This is a nail. This is not going to build the house for you. It's just a tool to get you there.
Great. So with
be a carpenter.
With all this, I hope you understand what Kris is explaining here, how we move between the nodes, because Kris always shows things very, very fast.
Yes.
Let's bring you back, Kris, because we're way beyond the 15 minutes that we thought we will do.
Yes.
Let's see your camera back. Okay, and now I need to do this back, sorry. Thanks, Kris. As usual, every time we start to discuss about something, we go sideways or two sides or whatever, because it is interesting, and it's you care a lot about this, and usually when I listen to your podcast, it's pretty funny when you start to talk about the how do you call it, the Kris's episode,
my best
corner.
practices.
Yeah,
come on,
the best practices. So
I get my own little weatherman section.
So definitely, and for you out there, it's not easy to do what Kris is doing to help his developers, right? It's not easy for developers to run static analysis or any other analysis tool or understand, or, oh my God, what do I do now? But we have folks in each company. I hope we have folks in each company, but if not, you should have folks in your company that are the security champions that do understand better. And then they can look at tools such as AppScan Source or others, evaluate and talk to the developers. Hey, Mr. Developer, why don't you use a prepared statement? Oh, I can't, I don't know. Here's the problem, you see.
How dare you?
You should have.
Statement. That is all. You get nothing else out of this. Let it be that, please, dear God.
Exactly, and here's the proof of why it's not good enough. And yes, static analysis, while it's more of theoretical, it can show you proof. Hey, it came from here. You didn't do anything, actually. It went here, right? So that's, I think...
And even if you did something, I think another key takeaway is make sure your sanitizers do what you say or claim they do. I have yet to see a homegrown cross-site scripting filter work. So.
Yeah, and coming from the DAST side, I think this is one of the beauties in the DAST side. If you are looking at the DAST, you can see all the multiple variants that the security research team that are behind the DAST tools implement, develop. So yeah, I may escape that tag, but did I escape that encoding, that basic support encoding, that HTML encoding?
Just wiping out script and script is not enough.
Yeah.
At all.
Yeah, just escape the greater than. No, that not working for you. So use the tools, use the method, and as Kris mentioned in the last podcast, there are, like, when you were talking about the algorithm for encryption, right? There are very, very smart people out there that build libraries to help you. Use them. Not saying that those are bulletproof, but when those will be, breached, you will know about it. There will be a new method. You can fix it, but definitely it will take longer to breach them than what you wrote. No offense.
Yeah, I don't think you can outmath the people that built these algorithms, no matter how much you try with all the Googling in your heart. You cannot outmath the folks that built them.
Yeah.
So you just can't. They might be able to outmath themselves, but that's why they make them.
In time, yeah. So with that in mind, thank you, Kris, for joining again.
Yeah. I appreciate you having me. Let me talk about all the greatness that is SAST.
Always. And by the way, Kris showed in AppScan, I think you have a version that wasn't out yet. I saw one of the menu items changed.
I did. I didn't want to show it just yet.
Yeah, because
we're adding fixed grouping to the on-prem, which will make going through giant lists of findings even easier.
Yeah, and that version of on-prem will come early next month. We will have a launch, and Florin will come to the show and show you how the fixed group is used, so we didn't show it now. Thanks, Kris.
It's going to be cool.
It is. Bye-bye. Till next time.
All right. Bye, everybody.